This session is supposedly called Unlocking the Power of Regular Expressions with PowerShell. And the idea is, even though I know a lot of you, and I've talked to a lot of PowerShell people who are really experienced, they are still afraid of or don't use regular expressions. How many of you are like that? Okay, a few, good. And which means it's probably twice as many people. This is all a safe space here. So what I want to talk about is kind of give you a feeling for, this is not that scary, it's not that complicated. It can be if you jump right into the deep end of the pool. We're going to start in the kiddie end of the pool and wade our way down, and we'll give you some basics about how to look at a regex pattern, how to build it, and then we'll look at some reasons why you should be taking the effort to learn regular expressions. So I finally remembered to put the sponsor slide back in. It's very good that we have these people, otherwise I wouldn't be here. All right, again, if you want to know all about me, the github.io link is the best place to go, or find me because this is my last day. I will be flying home tomorrow. All right, so what is a regular expression? It is nothing more than a way of describing a piece of text, a string. And it's based on a long established set of practices and standards that the industry uses to describe, what does this string look like. It goes all the way back to 1951, even older than me. It was then incorporated into Unix, which means it was then incorporated into all the other languages that Unix begat. This led to grep, which many of you know. Maybe you didn't know what it stands for. And PowerShell, of course, supports, via the .NET framework, the full regex library. And PowerShell actually makes it quite easy to work with regular expressions. The tricky part, which we'll get to, is building the pattern. But does not have to be complicated. So why do we care? Some use cases. Validating data is probably the biggest one. I need to make sure that maybe when I've got a function and it takes a computer name, but I only want this to work in my environment, and my computer names have a standard format, and I can express that format in a pattern. That way I can validate that the computer name they're giving matches my pattern. Or say you're doing something with Active Directory, and I need to make sure that the new computer account I create follows that pattern. Regex or regular expressions will help with that. Finding data. How many of you have to scour through gigabyte log files or text files? Regex can make it easier to find the data that you need. Or fixing data. There are things we can do, such as splitting on a string based on a pattern. We can also do things such as replacing, saying, hey, if you find this pattern, replace it with this other string. Some of the stuff you may have done already with some basic PowerShell commands. So, patterns. In North America, this is what a phone number looks like. It's probably close to Europe and other parts of the world. So it looks like a phone number. This kind of looks like an IP address, right? We recognize as IT pros, yep, that's probably an IP address. That's a UNC. Again, there's a pattern to that. So all regular expressions are doing is allowing us to programmatically define what those patterns are. So this is one way, and this is the tricky thing about regular expressions, is there's always more than one way to do it. So this is one way. I'm not going to try to explain it now. We'll get into some of that. Phone number, IP address, UNC. Now, yes, if you're new to regular expressions, incredibly cryptic, you think, yeah, I can't do that, and you walk away and go to the bar. You can still do that, but just hold on a second. So the way that we build these patterns, and I'm not going to go through all of this stuff because it's all in the PowerShell help, a regular expression pattern is based on building a regex pattern string using primarily classes. These are pretty much the only classes you need to memorize off the bat. They are case sensitive. I think I have a slide here. So /w is any word character, any alphanumeric character or number, and the underscore. Digits, non-digits, white space, non-white space. So you can kind of see the lowercase versus uppercase. You can read help about regular expressions and see this exact same table. We then take that class, and we're going to add a qualifier to it. You can kind of see what they look like there. And then there's some special characters that we use in regex building. The period means any single character. We can match on at least one character that's in the bracket, so in this case it would be XYZ. We can match on a range of characters. This is case sensitive and only works for alpha characters. Match on any character except what's in the brackets. We're talking about the anchoring beginning and end in a little bit, and then the backslash is the escape character. Because there may be times where you want to match on something, but it involves one of the regex pattern characters, and so we need to escape them. So basically, if you're trying to match on any of these characters, you'll need to use the escape character, the backslash. So let's say I've got this piece of string here, this data, and I want to pull out the date that's inside the square brackets. Okay, I don't care about anything else. I just want to tell PowerShell, hey, find me the date in square brackets that's in this piece of text. And of course, once you can do it for one thing, it could be 1,000 lines of code, and I can pull it all out. So here's how you would build this. So there's the actual pattern. We're going to go through and show you how this all works. So I need to match on that literal open square bracket. Now, because that's a special character, I need to escape it. All right, so I've got the backslash square bracket. Then I want to match on any digit or the dash. If you remember from the little table, /d is the class that represents any digit, and then I'm also matching on a literal dash. Because they're in square brackets, that tells the regex engine, look for anything that matches what's in the square brackets. And I want to match one or more times. So that's why I have the plus symbol. And then I need to match on the closing literal square bracket. So that's why the little string that's underneath the bolded text, that's the pattern, and that is how you would describe that pattern. Everyone good so far? I know I'm probably jumping ahead, but I want you to see that if you take your time and do it one little step at a time, it's not that difficult. So really what you would do if you're just getting started is, you'd save that to a variable and you build your pattern, and I'll show you in a moment how we do all this in PowerShell if you've not done this before, and say, okay, what do I do to match on that open square bracket? Once you figure that out, which you would see is the / square bracket, then you go, okay, now how do I match on the numbers? Next part. So don't try to write the whole thing all at once. Just try to build each little match from the beginning until you get everything that you want, okay? Too many people try to write the whole thing at once. It doesn't work. And then they try to change the whole thing. It doesn't work. Do one little match at a time and then add on to it, and you won't destroy your liver drinking heavily. And then the result is what's in square brackets with the number. All right, so let me go through this time frame. Let's see how far I can get with demos. Again, everything is up there. I'm not going to go through every single demo that I have, so make sure you grab that. What's that? Now, it still thinks I'm presenting. I thought I closed it. Come on. Come on. I'm not presenting. Oh, it changed. Let's try to duplicate screen. Come on. It's thinking. There we go. Yeah. The projector is a little finicky. All right, so let's talk a little bit here quickly about operators, even before we get into regex. Because there's another operator, and just to make sure we're all on the same page here, the like operator. The like operator kind of does regex type pattern matching, except it just uses a wildcard character, the asterisk character. So I can run a command like get process include username, where the username is like something Jeff. So I got star Jeff star. And let's do the whole line, not just that. Typically works better. All right, so there you can see that matched. And there's also a not like operator, which obviously is going to give me just the opposite, right? So you can actually kind of use some really fundamental or really basic kind of wildcard, very generic regex kind of matching, just with like and not like. Okay, very simple, not that not that difficult. So let's get then to some of the basics here. So in PowerShell, we're going to use the match operator, at least to start with, just to understand and test our patterns. So I have the string Jeff, and I want to know, hey, does it match on my regular expression pattern? Now, what is that pattern? Slash lowercase w means any alphanumeric character or the underscore. So when I run that line, all right, so I get a result of true. Whenever you run the dash match operator, you will get a built-in object called $matches, and it will show you what it matched on. Regular expression patterns will match until they stop matching. So I told it, hey, match on the single character. So it matched on the J and then stopped. So now I can see what it matched on. Here I match on multiple characters. And because it's the whole string, there's nothing after that, I got to get the full match, okay? So you can see how this is really not that complicated if you just take the time and don't panic about this. PowerShell, as I mentioned, stops at the first non-matching instance. So if I have this string here, some funky version of PowerShell, it matches. Now, what do you think $matches is going to show me? Just in your head, see if you were right? Because a space does not match the pattern, and so regular expressions stop there. And I just match where I told it to. All right, so this is true. We get a little more complicated here now. So I've got capital P. Now, let me make this mention real quickly here. For the most part, PowerShell regular expression captures are not case sensitive. You can make them that way, but they're typically not case sensitive. So I can do capital P, that I could also have done lowercase p and it would still have matched. So I'm looking for a P character. That sounds kind of weird. Either A or O, W-E-R, and then the parentheses is a grouping, like it is in math, and other like sub-expressions we would do in PowerShell. So it's saying, hey, look for the little substring, SHE, and then look for an L, and then one or more instances of the preceding character, in this case, the L. So with that in mind, do you have an idea about what this matched on? So the regular expression engine kind of breaks up what it matched on. The zero element is the full match on the full pattern. The other one, the she, is just that little sub-expression. So it also it's showing me where it matched. Any questions so far? Hard to see hands, so speak up if you have a question. Now this one obviously doesn't match. Now what you have to be careful of here, so far we've just been doing simple strings, is you have to watch what we call the float. So I've got this longer, kind of gibberish string. You can see I'm looking for my funky PowerShell variation. So that matches. What did it match on? So it matched on PowerShell, but matched on PowerShell with 3 L's. And that's not really what I want. I really just want it to be 2 L's. So I could modify the pattern a bit, or I'm going to start using anchors. So if you use the caret at the beginning of your string, that tells the regular expression engine match starting at the beginning of the string. Otherwise, the regex will look anywhere within your string to see if that pattern matches. Sometimes you want that. Most of the time, at least I don't. I want to anchor. I'm sorry, what's? Right, so what he said, the question is, what does that caret really represent? What's matching on? The beginning of, is it the beginning of the string or the line? So it depends on where you're using your pattern. In my case, it's going to be the beginning of the string. So if you are reading through a log file, it's going to search at the beginning of the line, which may not be what you want. You actually want the words. In that case, you would not want the anchoring, or you'll have to break up that line and then string alerts. So there is a little trial and error. But yeah, in this case, it's really simple because I just have a word and I'm saying anchor at the beginning of the word. So in this case, I actually get what I want. The match 0, that gives me the full name because I anchored. Oh, I'm sorry. It anchors because I also included, the $sign at the end says match at the end of the string. So when you include both the caret and the $sign, you basically get an explicit match. Don't float, look exactly for this thing. And it did, and it found PowerShell in index 0. And then you can try the demos and try some of these other ones. So from a practical standpoint, let's say I want to do get process include username and find all the ones where it matches, starting with NT authority. So that gives me NT authority system, local service, and all of that. Or maybe I just want to find all the ones that end in system. Actually, end in /system. So I have /system, but because the slash is a regex character, I have to escape it, which is why I have 2 slashes. Let's try that. All right, so now I match on everything that's with system. It is possible to build regular expression patterns that say match, or actually find things that don't match this pattern. That gets really, makes my head hurt. Fortunately, in PowerShell, you can use the not match operator and just say, basically, start with a pattern that matches everything that you know works, and then flip it and just do not match. So in this case, I want to find all of the usernames, all the processes where the username does not match something that starts with NT, /S is a space, one or more word characters, followed by a backslash, right? Because that last backslash is escaped. Everyone with me? Oh, I did. Let's do the whole line. Well, here, let's. So the not match is basically, I'm filtering out everything other than a username. If I were to change this to match, so those are all the matches, and I want the opposite of that. I don't want to see those. I want to see everything except these, and that's why I went with, oh, I see what you're saying. The first part of my, yeah, sorry. I understand it. So the question is about the first part of my where object. There are some processes that don't have a username, and so I'm filtering out those by saying, only give me processes where the username is not null and my regular expression pattern matches. Sorry, I missed that. Forgot about that little part. All right, so let's use some patterns. Replace. Now, you know that did the same thing again. Let's grab the right line here. Try this one more time. All right, so string objects have a replace method. And the replace method you can use multiple ways, but it's really only designed to replace one character with another character. It's not designed, let's say I want to replace files. Oh, well, just in case you're wondering. Yep. All right, so that's the value. And if I want to replace, say, files with foo, it doesn't work because the method, the replace method, doesn't support that. It only really wants to do characters. I could replace f with x, but that's not really what I want. And the other thing to be careful of, if I remember right, the replace method is also case sensitive. But instead, I'm going to use the replace operator. Oh, take that back. I can't use the replace method, but it is case sensitive. So here, I did replace files with foos, and that did work, but it is case sensitive. That's a little tricky. What I tend to prefer is use the replace operator, because the replace operator is specifically designed to work with regular expression patterns. So let's say that I have this string here, $S. So I'm a secret string and an IP address. And I kind of want to hide that IP address. So I have my regular expression pattern that matches on an IP address. I can see what it matched on. I'm going to refine that. So now I'm going to use the replace method, or operator, sorry. So I'm going to replace, the first argument is your regex pattern, and then the second is what you want to replace it with. In this case, I'm just going to mask it with a bunch of X's. Now, it doesn't change S. $S is still the original string. The replace method and operator just write new strings to the pipeline. Okay? But now I have a little more flexibility because I can use a regex pattern and say replace everything that starts with F, some word characters, and then it ends in an S, and replace it with foos. And now I don't have to worry about things being case sensitive. Now I'm going to jump ahead just to give you kind of a larger practical example of this replace. And this is actually using some advanced regular expression patterns. So I have a function here called outRedacted, and it takes a hash table, basically of strings of strings, and then replaces, if it finds them, with the key. So the key is what I want to search for, and the value is what I want to replace it with. So I have this function here. Show you how this is going to work. So I'm going to run get win event, searching for event ID 4648 in the security log on my computer, logged in as me. I'm going to, let's just do this for the first part so you can see if I did this right. Password. All right, so you can see I've got like my username and computer name. I want to hide that. I want to redact it as the fancy government terms. I'm going to rerun that command, pipe it to my function. And now I basically I've hidden or replaced that information. So now if I need to export or show an event log to someone and I need to protect sensitive information, there, I can do that. The power of regular expressions. All right, let's go back here. How are we doing on time? Splitting. That's another common task that you're going to do with regular expression patterns. So here's $S. And I want to split $S on, here's another pattern. So /D is a digit. I'm using a qualifier of 2, 3, saying I want to match on a number that is at least 2 characters long, or 2 digits long, I should say, but no more than 3. Because you can see I've got some numbers in there, and they're varying in length. I want something that is at least 2, no more than 3. And I want to split the string on whatever matches. So there's $S. So there I was able to split. Now, I could also do this. I probably should do this in the demo. $S verify, or as I'm testing this. So I just replaced on the 2 on the 12. Oh, okay. Yeah, that's what I wanted. It's not what I was expecting there, but let's move on here. So there's a lot of fun things you can do with splitting. If you're getting a long string, because some of you guys get log files that are generated by some application at some machine generated line of text that's got all this other stuff, but you know that there's certain information that you want. Then if I split it, I can then process it a little bit easier. Or the other thing I could do is I could replace the match with something like a comma and turn that then into CSV format. And then I can import it with import CSV on that line. So let's look at this from a scripting point of view here. Most of you probably know that there is a parameter validation called validate pattern. This looks scary, doesn't it? Got all those slashes. A horror movie. Can you kind of figure out what that pattern is trying to say? Yeah, so it's trying to match on basically a UNC. So UNC starts with a //. So I need to escape both of those backslashes. Oh, and I'm cheated because if you read the help message, it tells you. That way, so if someone runs the code, I'm not going to run the code, you can try it yourself. If someone runs the code and they don't put in a UNC, the parameter will fail and the function won't run, which is what you want. Because you need to keep in mind, when you're running a function, you have no way of knowing how the user is going to get the parameter value that they're going to pass to the function. Don't assume that they're just typing it out interactively. Because even if they're doing that, they could type something wrong or mistype it. They could be running some other code that's pulling it from God knows where. So don't assume that every parameter value gets entered perfectly and is being done interactively. You don't know that. That's why you want to have validation, because I'm an old school IT pro. I don't want my function to get running 3/4 of the way through, changing whatever it's changing, and then blow up. I don't want that. That scares the crap out of me. If it's going to fail, I want it to not even start. You want to do everything you can to make sure that your function is going to run successfully. Pattern or validation is a key element to that. And we use validate pattern is one possibility. And let me show you a few online testing things here. I'm just going to go right to the one that I use all the time, which is regex 101. Come on. Now, what's nice here, let me see if I can do my demo, because I have. Nope, wrong place. You put your data that you're searching down in the bottom. So this is just basically information from a log file. And then up at the top, you can start putting in your pattern. So let's say I want to search for one or more strings, and it highlights. And then also there's references about the different patterns, and then it will also explain how it's matching. So I want to find code. So I have a pattern here. So I wanted to find the time string. Yeah, question. Oh, the flavors. So the question is, what about the flavors? I typically just use. Oh, I get to be. They've expanded this. Those are some new flavors I haven't seen before. It shouldn't make much difference, but probably C# probably would be the safest bet. You can see it didn't really change anything. And the reason I show you this is that oftentimes it's easier to build your pattern outside of PowerShell, like in a tool like this, and then copy and paste it back into your code. There are some VS Code extensions. I've tried some of them, maybe because I just find it easier to work this way, but you can certainly search for that. And I did not write this pattern from start to finish and hope that it worked. I started from the left and matched each of the characters that I wanted, and I believe, I can't see my pattern. Yeah, so that matched. I'm not using any anchoring, so it's not floating if it happens to find it at the beginning of the line. So once I know that, then I could copy that, put that into a variable, use the match operator, or whatever I would want. All right, so another reason that you might want to use regular expression pattern is with the switch construct. This is really handy. Switch, if you may not know, has an option to create a regex match. So I am going to have a little switch here on a phone number. Again, this is a North American phone number. So you just need to make sure you use the -regex switch on the switch statement. And then you have your set of patterns that you want to have the switch match on. So if my pattern matches $phone, I know it's a valid phone number. And I'm just going to display a message in green. And then because that's all I really care about, I'm including the break keyword because I don't want it to bother going on with the other matches. Sometimes you do. You may want it to search other matches. In this case, I don't. If it matches the second one, then I'll say, oh, I can't find the error code, and so on. So I built patterns and tested them that for the most part should give me the appropriate error message. So if I run this switch, and then I have a default message. So I found a valid phone number. If I were to change this, because I took out the hyphen, so using a regex switch can be very handy. Nice way of providing a little error handling or validation, or even just deciding how you want to process the data, depending on whether it matches or doesn't match. And then the last thing I want to show real quickly here is selectString. So selectString allows you to specify, even though we use it a lot with just plain text, you can actually create a regex pattern or use a regex pattern and say, look for this in the string, look for this pattern. This is kind of greppy, if you will. So if I wanted to, let's see how badly this is going to take to run. I'm going to search all several thousand of my script files for the string requires version 2. I'm afraid how long this might take. Oh, there we go. All right. Now here's the tricky part. Because if you want to do something with this output, this is not just a string. This is selectString is writing its own type of object to the pipeline. And the reason that I saved that to a variable, $v, is so that you can see that it is a match info object, and you can see the properties on that. So I could let's do the dollar. Let's try this real quickly. So I'm searching for any script file that has a required statement for version 345/0. Or I'm sorry, .0. So how many files of that do I have that all got saved? So I've got those types of matches. So I'm just going to group them on the matches object and the value property. So at least in the root of my scripts folder, those are my old version files that I have, at least where I took the time to put in a found require statement. And then here's some other examples that you can play with. Let me go back to the slides real quickly. While it thinks. So a few gotchas. Remember, the comparisons with all the operators are true or false. Use the not like or not match instead of trying to invert things. Watch the float. Think about how exact you need to be. Do I need to be very specific? When you're building your patterns, make sure you test for things that you know will fail. A lot of times we build patterns and we just think, oh, it matches everything, but we didn't test anything that it shouldn't match on. We just are very lazy about it. You do have to be careful about that. And just because something passes, I may have an IP address, something that looks like an IP address, like my pattern I showed would match on 306.200.500, some matrix type IP address. You may still need to validate that that is a valid value. So just because it looks, there are regex patterns that you can build that will include some of that. They get really complicated. So you may want to just split that functionality out. You have to know your data. Regex works, like if I'm processing a log file, I have to know that the log file format is not going to change halfway through. Right? So you have to know in advance what your data is going to look like. It needs to be predictable and consistent. Some advanced stuff that you can do with look-aheads and look-behinds, optional matches, multi-line searches. There's a regex type accelerator. Got 30 seconds. Help topics. Some resources online. Some of them I have shown you. You can find me online. You've got 20 seconds for questions. Let me go back real quickly to the very beginning. So again, all the demos plus a lot of stuff that I did not get to are up there on GitHub. So go ahead and get them. All right, I'm done. Thank you.